Alright, welcome back to Explain 3. It's the last part of 20.2, which is independent events. So here we're going to be showing that events are independent. Again, using our two-way table. So here we're given a two-way frequency table showing 120 selected patients who have the same doctor. Determine whether a patient who takes vitamins and a patient who exercises are independent events. Okay, so they're comparing regular exercise to no exercise and vitamins versus no vitamins. And they took a total of 120 patients. So let's first define our events. So again, let's pick for vitamins, since that's what they want to have us do. For V for vitamins is the patients, actually let me change that, the patients who take vitamins. Alright, and then for the other event, which is exercise regularly, let's use E for exercise, so patients again. Patients or people who exercise. So this is vitamins and exercise, okay? So what we're going to do first is we're going to find a couple of things. We're going to find the probability of vitamins, patients who take vitamins. Patients who exercise regularly, and then last but not least, those who, take vitamins and also exercise. So let's go ahead and fill in these spaces so that we know what we're finding. We're going to look at our table for these things, okay? So for patients who take vitamins, all right, out of 120 patients, how many take vitamins? 60. About half, right? Out of 120 patients here, which is our total, I call it total because it's kind of where the total and total cross. How many exercise total? 76 or 44? 76, right? Alright. And then last but not least, out of the 120 patients, notice how the denominator was the same throughout, how many of them exercise and take vitamins? So we're looking for where the vitamin takers and the exercisers kind of cross. What number would that be? 48. Okay. So now what we're going to do is we're going to compare this percentage. So I will take some time. Go ahead and calculate that out. 48 divided by 120. Go ahead and calculate that out. And you should have gotten about 0.40 or about 40%. Okay, so now what we're going to do is we are going to calculate the next thing, which is to compare this percentage we just found, which is about 40%, compare it to if we were to multiply our event of vitamin takers and exercise people. Okay, so I'm going to go ahead and multiply these out and see how they compare. So that's 60 out of 120 and 76 out of 120. Let's work that out. What would that be multiplied to? And that would be about 4,560 over 14,400. Let's go ahead and divide that out and see what our decimal value would be, which is about 0.316 with the 6 repeating. And if we change that to a percent, that would be about 31.6. 6% with that 6 kind of repeating. Okay. Alright, so now that we kind of have both of these, we can kind of determine if these events are independent or not. So my question to you is what we found for VE, which I'll highlight in a color so you can kind of see it, with what we found for VE, which is that right there. Okay. How does it compare to, and I'm going to pick a different color so we can kind of see, to what we found when we multiplied these two together? Are they equal or not? Take some time to think about it. Look at the numbers. And as you can see, they're obviously not equal. So therefore, unfortunately, these are not independent. All right, let's go on to the next one. So again, they're going to give us a two-way frequency table showing 60 randomly selected children at an elementary school. Determine whether a child who knows how to ride a bike, and they're comparing that, how to ride a bike, who knows how to swim, are independent or not. So they're always going to just define our events for us. They say let B that be the child knows how to ride a bike, and S for a child knows how to swim. That's kind of cool. So we're going to find our event B, S, and B of S. So they already define everything for us. Let's go ahead and fill in some blanks. It says there are blank children who know how to ride a bike. So out of the 60 total, notice how that pops up not once, twice, but 3 times. They're going to use that 60 a couple of times. They want to know how many out of the 60 know how to ride a bike. So here, they know how to ride or don't know how to ride. So what number would I put here? 45. So there are 45 children who don't know, know how to ride a bike. And we can reduce that. In fact, go ahead and take some time and reduce that now from 60 to 4 and 45 to 3. You could also use this whole number. It's totally fine when we actually figure this out. Just like we did in the last one, it's fine. But you should know how to reduce by now. So it says there are blank children who know how to swim. So let's look at our totals here. So there's those who know how to swim and don't know how to swim. So how many of know how to swim? That would be 40. So 40 out of 60. Let's go ahead and reduce. Why not? So 60 reduces down to 3. That means 40 would reduce down to 2. All right. And then last but not least, there are blank number of children who know how to ride a bike and swim. So how to ride a bike and how to swim. All right. And we're looking for where the students who know how to ride a bike, yes, and who know how to swim, yes, cross. So what number would they cross at? At 30. So that would be 30 over 60, and let's go ahead and reduce that. Now it would be about 1/2 or 50%. So let's go ahead and multiply these two together. We got here and here. So that's 3/4 and 2/3. So 3 times 2 would be 6, and 4 times 3 would be 12. And we can reduce that and make that 1/2, which as a decimal value is about 0.50, which is about 50%. So comparing these two, what we got when both they know how to ride a bike or swim, which is 50%. If we multiply these out, it's also 50%. Are these equal or not equal? Equal, right? So that means that these two events are, in fact, independent events. Just as it says here, it says stop and do the problems in your packet. Go ahead and do those. On the next video, we will be going over the homework.